version 1.1, which is still actually in the pre-release version actually. Then they make version 2 available. So while version 2 is available and there might be some changes made to version 2, you can see here clearly that version 1 will also have some changes made to it actually in this diagram that we have here. So eventually they will go up to release 1. Release 1 is basically then what is released actually into your production environment actually. And your versions actually is remember, your versions actually is different from your releases. So your release is just the, the 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 event that occurred actually for your software to be made actually available um, from actually the environment, your local environment, your working environment, onto a bigger group actually. And the release then actually is basically copying your version actually over to a new platform actually. So we see that here actually we'll have multiple versions. We'll have version 1 that might have actually a number of changes made to it. Then we will go to version 2, and version 2 will also have some changes made to it. We see that actually when we have version 3 in this diagram actually, version 3 will incorporate actually all the changes that were made to version 2, version 2.1, version 2.2, and 2.3 will be included into version 3. And that's actually how your multi-version system development operates. These are just terminology and things that we use in configuration management. We talk about a baseline, we talk about branching, we talk about coding, we talk about configuration version control, we talk about configuration items or software configuration items, and then we talk about a mainline. So these are just for taking note. I can't remember if I made actually any, if I assessed this at all. What I'm talking here is just the terminology, it's not the content in this unit. So there we're carrying on actually with merging, release, repository, system build, version, and workspace. You can just read through that actually for noting.
Thanks.
If we start moving over now to our version management, which is the first component actually of configuration management, let's look a bit deeper into this. We say that version management is the process of keeping track of different versions of software, components, or configuration items, and the system in which these components are used. So if we look at Windows, we are at Windows 10 right now. There will be different versions of Windows 10 in different parts of the world. And these versions, we know clearly that there is certain changes that were made, certain components that were made available, and this forms part actually of the version. So this is basically where we come actually normally, and we have to do some system updates on our machines actually, where we load patches and where we load actually various service packs and all these things actually. This has to do with this specific unit we're talking of when we talk about actually our various components that need to be upgraded, when we talk about actually various versions actually that we need to release or implement, and so forth. So it also involves ensuring that changes made by different developers to those versions do not interfere with one another. This is when we talk about actually version control. So programmer number one actually might have been working on a specific change request. That change request might have been affected actually by including the new upgraded component into a version that is made available. So while the first programmer might work on a change request, remember this is not a static system. It is constantly, as different users are um, being asking then actually for changes to be made to the system to fit their environment. So various change requests actually will be sent through to, and received actually from the by the developers actually, and they will then actually act on those. So therefore, version management can be thought of as the process of managing code lines and baselines actually. Code lines is basically when we look at specific areas, actually algorithms is built in the program, and baselines is basically where we talk about actually a number of components actually that form the system. So here we say a code line is a sequence of various versions of source code with later versions of the sequence derived from earlier versions. So that what we're basically saying then actually, you will have actually a specific system. Changes will be made actually to the system, and changes are made actually in the source code, and then actually that source code actually then actually becomes the baseline actually of your new system. The baseline normally applies to components of systems so that they are different versions of each component. A baseline is a definition of a system. The baseline therefore specifies the component versions that are included in the system plus the modifications of the libraries used, the configuration files that you use, particularly the way maybe they So now let's move on quickly to the next one. Guys, my connectivity is extremely disruptive here. So I see there's a lot of system interruptions. So try and go slow, and we make sure that we not miss anything. So the baselines actually are basically baselines may be specific using a configuration language which allows you to define the components um, that are included in a version of a particular system. The baselines are important because you often have to recreate a very specific version of the system. So that's basically what baselines are about. So here we see then actually that we have various code lines. The code lines actually will include various versions of that, various changes that has been made actually to the system as well. And we will see that, actually, that we also use external components and libraries to it. So now our baseline version 1 will include code line A, maybe changes actually that were affected actually in code line and externally component maybe x1, so that will form baseline version 1. If you compare that actually with baseline version 2, it might have a different um, code line, a different from A, B, a different set of libraries, and a different set of external components. So this is basically just an illustration of how your code lines and your baselines actually are being used actually for a system. So now version control systems are basically systems that identify, store, and control access to the different versions of a component, because you don't want your source control, or your source, your system source okay, to be accessible to everybody. That's why we then actually use version control to the source components that we have. The source, there are two types actually of modern version control systems. You have a centralized one actually,
Hmm?
and this is basically where there's a single master version repository
Well,
that maintains all versions of the software components that are being developed. So if you have actually only one team that's working at one specific location, you might actually then actually look at a centralized system. We also have a distributed system where multiple versions of the component repository exist at the same time. Now, Git is a very widely used example actually of the distributed actually version control system. Git is basically a Git and GitHub. These are open source version control systems and things that are being made available in the industry for developers to manage version control. Now, the key features actually of version control systems are basically it's dealing with release, a version and release identification. It deals actually with change history recording. It deals actually with support of independent development. And the reason why we talk about independent development actually basically means actually that two different programmers actually can work independent from one another, because each and every one of them will have their own each and every one of the developers will have the independent working space, and therefore they will then work independent from one another. We talk about actually one other thing actually is project support and then storage management. Actually, you want to make sure that these actually are all some of the features and things that if you want to use a version control system, that it caters for these features in the version that you are using. Now, there are public repositories and there are private workspaces. Public repositories are basically there, and
this
public
guy,
repositories and
this
private
guy wants to
workspaces
travel
are there to
20 minutes
support
ago.
independent development without
Oh,
interfering.
so I finished.
Version control systems use the
He's just
concept
wait.
of a project repository and a private workspace. So basically, how this works is you will have a project repository where all the components are stored. If a request is assigned to a developer, the developer will then actually access the public repository, copy that component over to his laptop or his workstation, where it will create actually a local version. The local version will be a working space environment actually, and then actually the the local working space actually will then actually operate independently from the public repository. So while programmer number one actually might have copied a
What happened
component
to Dragon?
over to his workspace,
GitHub.
programmer number two
So,
might have copied the same component over to a different working environment actually,
this
where
thing,
he also need to maybe
this
look
thing
at
has a message
certain
password.
other things actually that need to change actually. So the project repository maintains a master version then of all components, and it is used to create the baseline for the system building. When modified components, in other words, the developer's copy, are checked out, so this is basically how your project repository will work. It will take a component, it will allow a programmer to copy it to his environment, his working space. In other words, it's checked out. And many times actually your how your public repository will work is that to avoid conflict on components actually, it will only allow one user read and write access to that component. In other words, it will check it out of the public repository. So if a component is checked out of the public repository, the second programmer that might want to access that might sometimes not be able to check it out also because there's already an exclusivity assigned actually to programmer number one. And for that actually then actually for the second user for the second programmer actually then actually to access that and make changes to a component actually, he will unfortunately have to wait for the first programmer to finish his work. And when the programmer copies moves back into the repository, he checks it in again, and it makes then actually the public repository will actually make it available to everybody else then actually for checking out purposes and things. So when they have finished their changes, um, like I said, actually, the changes of the components are returned into the repository and is checked in.
Ntsari muthathu mlori ya GitHub kama. Muthathu mlori ya GitHub. Asa kama. Kama.
So now, if you look at our centralized control version, developers check out components or directories of components from a project repository into their private workspace and work on these copies in their private space. When the changes are complete, they check it back into the repository. So if several people are working on a component at the same time, each check out from the repository, each one actually need to check it out from the repository actually. So now it depends on how your repository is being set up actually. If the component has been checked out, the system wants other users to check out the component if it has been it the system wants actually other users wanting to check out a component that is already being checked out by somebody else. So in other words, what the system basically does here, it places exclusivity on that specific component because many times actually a component can only be checked out once. When it's checked out once, nobody else then actually can make any changes to that. Just because think about this logically, if a component has been checked out of the repository and changes are being made to it actually, if somebody else is um, checking out the same component from the central repository, there might be a possibility that when this component is checked in by more than one person, that one will override the work of the next person. Actually. So that's why it uses exclusivity here, and if and it basically means that if it's checked out by one user, nobody else actually can check it out again to overcome the challenges that you have actually in overriding each other's work. So this is actually when you have actually how it works. You repository check in and check out. Alice actually might actually have her own working space, and so might Bob have his own working space too. And you will see here that the various components actually that are from the version control management, the central repository, those are the various components actually. And if it's checked out A0100, it might be checked out by Alice actually. It means then actually that Bob will not have access to those that Alice has been checked out. And it also means actually that the repository or the components that Bob has checked out is not available for Alex. So there's basically a constantly checking out of components, making sure that they are changes are being made actually, and then check back into the question here. There was a question there. There was a comment. Let me just go back to that comment now. It has something to do with mergers actually. Sorry, I didn't see the thing. Can you just repeat it vocally so that we all can hear what you were saying? My system is a bit slow here this side actually, so yes, it basically says it merges changes as well. Yeah, you're correct with it. It's
Yeah,
not
so
just actually
it doesn't override always. It also merges the changes.
it doesn't override always. What if two users actually are checking out a component? That's what I was talking of actually. Where you have two users that check out a component actually, there might be a possibility that one will override the others when they check it in.
Yeah,
It's for that reason actually where you have actually a check in and a check out.
yes, you're right. And it also
Okay.
matches the changes. If we were working on the same page, like on a certain piece of functionality, and I wrote a certain piece of code, and somebody wrote a certain piece of code that side, it is going to merge the changes, and it will ask whoever is checking in the changes if that person wants to make the changes or override something like that.
Yes, yes. Yes, but that is actually in an environment actually that where more than one person actually can is allowed to check out or check out actually components. If it is in an environment actually where there is exclusivity in things actually, it doesn't make sense to ask you to override it because changes and things you've taken a copy that is already in the public version, made changes actually, and when you check it back, it's supposed to override what is in the public repository.
Yes, you're right.
Okay, let's move to the next slide. So now we have actually what we call distributed version control. So obviously we looked at centralized actually version control. So with centralized version control, you will have actually the setup in such a way actually that only one person can copy or check out a component. When you have distributed version control, this is now a bit different actually because here a master repository is created on a server that maintains the code produced by the developer team actually. So what happens actually, instead of checking out the files that they need, a developer creates a clone of the project repository that is downloaded to installed actually on their machine. So in other words, actually, the previous one when you have centralized actually, there will be only one master copy. But in this case, when you have actually a distributed version control actually, what happens is actually that you copy the whole repository over back to your onto your working or your workspace actually, and then actually with this one actually there might then actually become possibilities now actually of you might being able to overwrite um, components actually that is in the master repository actually. So developers work on these file requests and maintain these newer versions on their own private repositories for their of their own computer. So what we're basically saying here is with a distributed version control system actually, your local environment actually also becomes actually a repository, unlike actually in a single centralized version control where there was only one repository and your workspace was never created like a repository. It was only a workspace. This case here, with a distributed version control, the workspace also becomes now a clone of the project repository. And with that case it means that the local repository need to be updated constantly to keep actually in sync, almost like with a master repository. So when changes are done, they commit these changes again, update they commit these changes and update their own private server repositories. In other words, actually, if you have a distributed team and distributed version control, the private or the workspace where you will have actually your private actually repositories need to be updated. So in other words, you commit changes to the repository, and your version control system will handle that actually. They need to push the changes then actually to the public repository from the private server repository. It need to be pushed directly to the public repository. So it's almost like a bottom up approach here, actually, where your private repository might have the changes of things, and those changes are affected onto the master repository. So here, for example, we see how what happens actually when a repository is cloned. You will once again actually have your two developers here, Alice and Bob. We will have actually a master repository that will contain all the components. Alice might actually have actually some components on her private repository, and Bob actually might have the same, or there is differences actually in this case actually. And when changes are made to Alice's actually repository, it need to be pushed to the master repository, and the same with Bob's also. So obviously what this thing does actually, what this thing shows us actually is just creating the clones. It takes actually components actually of the master repository and replicate that actually onto the repositories actually of Alan, Alice actually, and Bob here. In other words, Alice and Bob are basically developers, and they will have their repository will be their working environment actually that they will have. So the benefits of distributed version control are they provide a backup mechanism for the repository. So if the repository is corrupted, if your public repository is corrupted, okay, work can continue and the project repository can be restored from the local copies. It allows actually for offline working, so the developers can commit changes if they do not have network connectivity. So once again, actually, with a with a centralized repository, it is network dependent. With a distributed one, actually, if the network goes down and things actually, it doesn't really affect your team. So the project supports the default way of working. So developers can basically compile and test the entire system on their own machine and test it clinically before they actually push this back into the public repository. So these are the benefits that we see on the distributed version control. So now we have what we call open source development. Open source development is basically from a version control perspective, is distributed version controls are essential for open source development. We know clearly with open source how open source basically works. You take a component, you you copy it onto your environment, you improve on it, and then you need to recommit it back and make it available to a larger community. So several people may be working simultaneously on the same system without any central coordination actually. In the open systems, open source world, actually, as well as a private repository of their own computer. Developers may maintain a public server repository to push which the new versions actually of components that they've developed actually. So that's basically how it works actually. So it is then up to the open source system manager to decide when to pull these changes actually onto a definition system. In other words, actually, how it basically works in an open source environment, you might actually have actually a myriad number of private repositories, and it's up to your open source system manager then actually to basically pull those changes and things actually from the various repositories actually. So unlike actually with centralized actually source control, actually it is where it's a push. This one is the opposite actually, where it's a pull. So these are basically just a grammatical way of showing us. You will have your project, your definition, project repository. You will have actually then actually the various other repositories actually, and we can clearly see actually how these guys push and pull things actually from the definition definitive project repository. We talk about branching and merging rather than a linear sequence of versions that reflect changes to a component over time. There may be several independent sequences actually, and at some stage actually it may be necessary to merge code lines, branches actually, to create new versions actually of a component that includes all the changes that have been made. Now here we see where we have sorry for that, let me just go one back. Here we see the difference between we see the difference between merging and branching. You will have code line 1, which is a version 1, and then actually changes will be made to that, and from code line 1 actually you will then actually have code line 2. So in other words, code line 2 is a branch of code line 1. Changes will be made again from code line 2. You will have code line 2.1, and then eventually the changes that were affected actually um, in version 2.1.1, 2.1.2, 3, and 4 will then be merged into a update actually, or a version actually 4.2, where all the changes actually that has been made actually to the code lines are collapsed almost actually into a specific version actually. So now there is some storage management things that need to happen with this as well. When when version control systems were first developed, the storage actually was one of the most important functions of these. You can imagine actually when storage basically was quite expensive, actually it was a big issue. But disk space was expensive, and it was important to minimize the disk space that is used actually to develop different kinds, different copies actually of the components. So instead of creating a complete copy of each version, actually the system stored a list of differences actually, and the deltas actually between the two were normally where the changes and things occurred. So this is actually what we're talking of. Actually, you will have actually your storage management using the deltas and things. You will look at version 1. There will be a delta 1, and then actually version 1.1. It will create actually a delta 2. Version 1.3, delta 3, and so eventually when you have actually version 1.3, there will be some on the source code level. Actually there will be also the 3 deltas, delta 1, 2, and 3 will be incorporated actually, and we're using the creation date actually to create the sequence between the various versions actually and the various deltas that we have. So now the storage actually storage management in Git, since the storage is relatively cheap now, Git uses basically a far alternative and a faster approach. Git does not use deltas, but rather a standard compression algorithm that stores the entire files and their associated meta information. It does not store duplicates of the file, but rather it retrieves a file simply involving decompression, and then needs to apply a chain of operations to it. So Git uses a notion of pack files, where several smaller files are combined into a indexed single file, and in that way they use a different approach to the delta and things that we've seen in the previous slide. If you look at the system build, system build is the process of creating a complete executable system by compiling and linking the files, the system components, external libraries, and configuration files. The system building tools and version management tools must communicate, as the build process involves checking out components versions from the repository managed by the version control system. Now the configuration description used to identify a baseline is also used in the system build tool. So we see here that the system build tool actually will need actually all those components. Otherwise, it will not be able actually to arrive at a executable system. Now we have actually what we call actually building platforms. The building platform is basically a system, a development system which includes the development tools such as your compilers, your source code, your editors, and all of these things actually are then actually basically made use actually so that we can arrive at a system and things actually that can be built actually. There's a build server which is used to build definitive executable versions actually of the system actually is what we're talking about here. So developers check in code actually to the version control system actually before it is built. The system build may rely on external libraries that are not included in the version management system again. So we need to take into consideration the target environment here. Target environment is basically the setup of the users actually. What is the setup of the users and things like, which is a platform to which actually the system executes. So in other words, what we're saying here is actually the environment actually can be we might actually you have a Microsoft environment or a Linux environment actually or a the Apple Store, Apple platform and things. So that's basically what we talk about actually when we talk about the the target environment. It might be an open source actually environment and things that we have also. So these are need to be taken into consideration when the system is built. So obviously these are the various components, and it need to pull in libraries, data files actually, your source files actually. There's going to be some configuration files. There's going to be some compilers and other tools that will be needed actually in the automated system that builds actually your automated system build. And then actually we'll also need to have actually some executable tests, and obviously we will then actually have actually an executable target system, and then actually our test results actually. So these are just actually all for just for taking note. I might not actually want to ask you anything with regards to how what are all the components that is involved in a system build.
No, already read that thing.
So these are then actually the functionality. We will actually build a system. We will build a script generation actually. We will actually look at integrating the version management system. We will then actually maybe minimize actually recompiling, because compilation actually can be very expensive on computers. We will then actually create actually a executable system will be created where will be some testing and happening, reporting, and then document generation actually from that. If you look at the system platform, actually, the system, the development system, which includes developing tools such as your compilers, your source code editors, are included here. The system, we build the server. The server build server actually basically is actually what we're going to use to build actually the definition, the executable versions of the system, and the server maintain a definitive version of the system. The target environment, like I said, actually, is a platform in which the system executes. Is it real time? Is it embedded systems? What you're talking about? Sometimes actually it's smaller, and it's smaller systems or smaller development environments, like for example on a mobile device. Moving on to the next. These are just actually a grammatical presentation actually of how the development actually the build and the target platforms and things are working. You will have actually your development system, where you will have your development tools, your private workspaces and things where you check in and out things into your version control and your build server. Um, your build server, your version control system will sometimes actually include or pull things from the private environment or push things through to your private workspace basically and check them back in. It will then actually push the components actually all to your build server. Your build server will actually then actually create a target system with a platform in mind. Now we talk about agile a lot. Agile building basically means checking out the mainline system from a version management system into a developer's private workspace. Now, with this, we basically saying this: building this system and runs automated results testically to ensure that the system passes all the testically. If it is not, that basically means the system is broken actually, and you should inform whoever checks the last baseline actually. So what we're basically saying here is actually that actually when a in agile development actually, when a developer is creating his own private actually workspace and things, one of the first things that need to happen actually, he must make sure that actually he has a system that works. Otherwise, there is a problem with the baseline actually from and the baseline actually might be actually components actually of a previous check-in actually that had errors in them. So make the changes to the system components actually. That's basically then actually from a developer's perspective and things, um, is to fix if there is any problems in the mainline system and things, it need to be fixed, and then from there build a system for his private workspace and then rerun the system testically. So this need to happen actually. It's a continuous process that happens actually. um, so it's a continuous process that happen actually until all the problems are fixed, and then only actually, can the changes be pushed back into the public repository. So these are still okay, some of the processes actually, or some of the steps and things that we follow in terms of building agile building. So we talk about then clear about continuous integration. You will have your version control, you will have your private space. So between the private space actually and your
Telelkot drink in it.
hello,
Siguma Mokangil, Telelkot drink.
can you mute your mic please? We just heard now you're ordering cooling.
Salanum cool. What is it train there? Salanum cool.
Can I ask that everybody mute their mics please? So this is just showing the continuous integration between your public repository and then your private workspace. So there will be a check article from the public repository into the private workspace actually, and we go through these various steps and things actually until we satisfied actually with the changes that were made locally, tested actually, and we carry on with that actually until all the tests has been test issues and things has been resolved. The system has been built actually. The changes has been committed to the version control management system and things, and from there the system has been built actually, and then version management system and things actually takes over again actually, and then actually we will have actually a system based actually on a specific version actually for users. These are the pros and cons actually of continuous integration. So the advantages from one of the pros is the advantage of continuous integration is that it allows problems caused by the integration between different developers to be discovered and repaired as soon as possible. So we have actually very short time actually once the error has been discovered, and then actually also fixed at the same time. The most recent system in the mainline is a most definitive working system. In other words, actually what we're saying here is actually that the working system and things like that will be the most recent one actually, because obviously your various programmers might have taken the time actually to fix the errors and things that occurred in their private space and things, and then that code and things that they had actually, or the components that they had actually in their private workspace has been pushed over to the centralized or the public repository and things. The disadvantages actually of this can be a very large system, and it takes long to build and test, especially if integration with other application systems is involved actually. So it's quite it can be quite tricky here because actually of the components and things that in the various systems and things actually, and you might actually want to change something in your system, things that have an impact on another system, and it's quite difficult sometimes to pick it up. So if the development platform is different from the target platform, it may not be possible to run tests if the developers in the developer's private space. So in other words, actually, if your developer actually is having a Microsoft platform, for example, actually, and your target system actually is working on a different operating system and things, you might not be able actually to run system tests actually on the private space actually. So now we talk about daily builds, and I'm not going to go through this one. This is for reading. We want to minimize recompilation, and the reason for that is there are tools actually. There are tools that support systems built that are usually designed to minimize the amount of compilation that is required actually. They do not they do this by checking if the compiled version of the component is available. So if it's not available, then they will do the recompiling. A unique signature identifies each source and object version control and is changed when the source control is edited. So that's basically where they look at how they pick up actually whether a component has been compiled or not. By comparing the signature of the source and the object code files, it is possible to decide if a source code was used to generate an object component.
It's just a question.
So here they talk about actually your file identification. They use actually modified actually timestamps, and then they use checksums for that actually. Some of them can use date stamps, and some of them actually are using checksums.
So I mean, what is it that you're gonna do? What do you want?
So obviously here is just
I don't know.
a graph actually in terms of pictures of how they do this. Actually, you will see that each and every